In this particular video, we're going to talk about power transmission, how power is generated and then transmitted to from the power station to the consumers. So you are going to realize that power stations are usually places where the power can be generated. Remember, there are different modes in which power can be generated. Number one, we can talk of hydropower, whereby water is trapped in a reservoir, and then when that water is released, it can be able to rotate the turbines, and these turbines are able to generate electricity through electromagnetic induction. There's other ways. Maybe we can talk of geothermal power stations, which make use of the hot springs of water that come from the ground. Then when that water comes through, it's directed through the turbines, which are rotated in order to generate power. So what usually happen in the power station is that electricity is generated. Then that power or electricity that is generated is transmitted to a step-up transformer. Now we can see at this particular point here, we have a power station that is generating power, and then that power is generated is transmitted through the cables to the step-up transformer. The purpose of a step-up transformer is to ensure that this power that has been generated now, voltage is stepped up. And what you need to remember is that a transformer is an electrical device that is designed in such a way that it can be able to increase voltage. So for this one, it's a step up, so it's going to increase voltage because we have AC current or alternating current is going to go through the primary coil, and that alternating current is going to set up magnetic fields around the primary coil. Since we have a soft iron core, this soft iron core is going to link those magnetic fields, and the fields will cut across the secondary coil. And now when that happens, when fields cut across the secondary coil, a voltage is induced in a secondary coil, which results to the flow of current. So something that you need to appreciate is that when a field cut across a conductor, then a voltage is induced in that conductor. That voltage is the one that results in the flow of current. So what happens after the power has been transmitted from the power station? It will be stepped up so that this power can be transmitted at high voltage. Remember, when power is transmitted at high voltage, is going to reduce power loss, as it's going to be transmitted through these conductors or cables and wires, which are good conductors. So this power is going to be transmitted whenever that power is about to reach the nearby areas where this power is going to be used. Is now transmitted or transferred into a step-down transformer. The purpose of a step-down transformer is to ensure that it's going to reduce this voltage now so that it can be able to be used. Now the voltage can be transferred to the industry, and the voltage can be sent to residential homes, and then you can see the reason as to why we are saying that this voltage has to be reduced so that the consumers can make use of that. Because if we are going to use the voltage the way it was at high voltage, it's going to lead to a lot of risks, like there can be electrocution. People can be get electric shocks here and there. So that's why we have a step-down transformer which reduces voltage to a level it can be used. I believe you can be able to notice that this step-down transformer, I've tried to magnify it at this particular point. You need to realize that a step-down transformer has got fewer turns in the primary coil. Rather, it has got more turns in the primary coil, has fewer turns in the secondary coil. So the reason as to why this is going to reduce voltage is because since we are having fewer turns in the secondary coil, when these magnetic fields which are created by alternating current at this point are going to cut across the secondary coil, what will happen is that less voltage is going to be induced in the secondary coil, so there will be also less current on the other end. So the output voltage for a step a step down transformer is usually less than the input voltage. As you are going to do your exams, you may be asked questions that indicate what's the equation that links and connects between a number of turns and voltage. This is the formula you are going to write here. You are going to say number of turns in the primary coils over number of turns in the secondary coil equal to the voltage in the primary coil over voltage in the secondary coil. Another formula that is going to be very important when you are working out questions to do with transformers is the equation indicating the relating between the power input and power output. Remember, in electricity, power is actually current times voltage. So what's going to happen here when you are told that a transformer is 100% efficient? That's going to imply that this transformer, the power that's getting into the transformer is equivalent to the power that is getting out of the transformer. So which will mean that current in the primary coil times voltage in the primary coil should be equal to current in the secondary coil times voltage in the secondary coil. So the main formulas that you need is this one and also this one. And also you need to understand how to describe a step-up transformer, and also you need to look at the features that indicate we have a step-down transformer. So basically this is what we ought to understand regarding transformers as far as Igcse Edexcel is concerned. So we're going to wrap up with other topics. So if you found value from this video, consider subscribing so that anytime we're going to upload another series, because it's going to be a series of all the topics that you ought to prepare on as you are preparing on your exam. Thank you for watching. See you in the next video.